Welcome students to my channel Pradeep Sir Classes, and today's we are just starting with the next part of moment of forces, that is chapter 1. And so today's I cover that these are the actually the key points. These are the key points of today's class. So the first one is moment of force, and the second is unit of moment of force. And I for the first class I just completed the concepts of moment of force. Actually, when we applied a force on a body, that is are pivoted and then it rotates, which is actually not free. A body is free, then if we applied a force, then it goes in a particular directions. But if that particular body is pivoted at that point, then if we applied a force, then it rotates. So the turning effect is called the moment of force, and basically the moment of force, it is completed in the first class. And today's the next one is what is the unit of moment of force. So for unit of moment of force, I memorize that particular concepts, that is tau equal to force into the perpendicular distance that is taken from that particular line of action of particular forces. So I suppose if this is a particular body and it is pivoted at point O, and if I applied a particular force along this direction, along this direction, so this is the perpendicular distance, and always you have to take a perpendicular distance if the force is given in along these particular directions, and then the moment is less than that value. So it is another concept. So when we applied a force and this is the perpendicular distance, then the moment is force, that is this is the line of action along which we can apply the force, and therefore tau equal to force into perpendicular distance. So this is the formula for calculating moment of force for a particular turning effect. So the next one is unit of moment of force. What is the unit of this physical quantity, that is moment of force, or it is denoted by tau. So unit, what is the unit of moment of force? This is the questions. Moment of force. What is the unit of moment of force? And so tau equal to force into displacement. So the unit of force is Newton, and for distance we take meter. So Newton meter is the SI unit of force. So the answer is Newton meter in SI system. And if we go to the CGS system, then it is for Newton, in place of Newton we can write dyne, or in place of meter we can write centimeter. So dyne centimeter is the unit of moment of force in CGS unit. So these are the answers, and this is the question number 1. What is the unit of moment of force? So for calculating moment of force, you have to memorize that particular formula. Then in place of force you can write Newton, and for distance you can write meter. So Newton meter is the SI unit of moment of force, and dyne centimeter is the CGS unit. So the second topic is clear, unit of moment of force in CGS and SI units. SI and CGS unit of moment of force, and it is completed. What is gravitational unit for it? What is the second, the fourth one is what is the gravitational unit of it? So what is gravitational unit? For the gravitational unit, we have to memorize the concepts of gravity. So gravity if this particular body have a mass of m equal to 10 kg, then earth drags it along towards its center with a force of m into g. So it is called weight. So weight equal to mg, that is 10 into 9.8, and this is Newton, so 98 Newton. So this is the force. And if we take what is gravitational unit, suppose 10 kg weight is the gravitational unit, 10 kg weight. So it means that if we so the gravitational unit of this one is for force. Yes, you have to remove the particular ones. So the gravitational unit of moment of force is tau equal to fd, or in place of f we can write kg weight or kg force into meter. So kg force into meter is the gravitational unit, or we can write kg force, gram force, in place of kg, gram force into centimeter, gram force into centimeter. So these two are the gravitational unit of it. And what is the conversion of this unit to this unit? And so we can write here, that is 1 Newton meter, 1 kg force into meter means 1 kg force. Kg force means 9.8 Newton. So 1 kg into 9.8 Newton, 9.8 meter per second square into meter. So into meter. So this is 9.8 Newton. Kg meter by second square means Newton into meter. So when we transfer a particular unit of moments into the gravitational unit to a particular SI or absolute unit, then this is the relationship. 1 kg force into meter, it is the gravitational unit, and this is the absolute unit. So this is the relation connecting between this is gravitational unit and this is absolute unit. So this is the relation connecting. When you go from, if suppose it is given 2 kg force into meter, so you have to multiply it with 9.8. So 1 gravitational unit equal to 9.8 multiply. You have to multiply 9.8, then you get absolute unit. So to get absolute unit, you have to multiply it 9.8 with gravitational unit. So we can actually write this one as 9.8 into gravitational unit equal to absolute unit in SI system. So this is the relation connecting between the two system of units. And if we change a particular, suppose gram, this is suppose 1 gram force into centimeter to a particular absolute unit, then you have to multiply 980 centimeter by second square into centimeter. 980 gram centimeter, sorry, this is equal to 980 gram centimeter by second square into centimeter. So this is gram centimeter by second, this is dyne, so 980 dyne centimeter. So 1 gram force into 1 centimeter equal to 980 dyne centimeter. So this is a particular unit SI system, and this is for CJ system. And this is absolute unit, this is absolute, and this is gravitational unit, and this is gravitational unit and this is absolute unit. So what are the different units? One, Newton meter. Second, dyne centimeter. Next, kg force into meter. Next, gram force into centimeter. So these all are the units of moment of force. So when we transfer a particular absolute to gravitational or gravitational to absolute unit, then the conversions are given. If suppose 1 kg force into meter is given, then you have to multiply 9.8 with it and you get absolute value. So when the unit is given in gram force into centimeter, then you have to multiply 980. That is, this value gives a 989 centimeter. So these all are the, this is the formula. That is, what is moment? Moment is a turning effect. Moment is a turning effect. When a body is not too free, then if we applied a force, if we applied a force on a particular body that is not too free, that is pivoted at a particular point, then the body takes a turn. And this turning effect is called moment of force, and it is denoted by tau equal to Fd, and its unit is Newton meter or dyne centimeter, or its gravitational unit is kilogram force into meter or gram force into centimeter. So these all are the concepts. And the next one is 5. That is, what is convention of clockwise and anti-clockwise movements. So the next topic is, what is the convention of the moments. So moment is a vector quantity. First of all, you have to write questions. Is moment a vector quantity? Is moment a vector? Is moment a vector or scalar? Yes, it is a vector. Yes, it is a vector quantity. So what is vector quantity? What is vector quantity? What is vector quantity? What is vector? The vector quantity. What is vector quantity? Vector is a physical quantity. A physical quantity which possesses both magnitude and direction is called a vector quantity. A vector quantity. So a physical quantity which possesses both magnitude and as well as a direction. So how we can calculate the magnitude? That is, we can calculate magnitude by a formula tau equal to Fd. And every physical quantity has a specific absolute unit. So its unit is Newton meter and dyne centimeter. And the next one is, if moment of force is a vector quantity, then what is its direction? So these questions is a specific rule. Suppose this is a body and pivoted at point O, clamped at O, and this is another body. Suppose this is another body and clamped at O. And if a force is applied along this tangential direction, that is F, and if we force a particular force along this tangential direction, or suppose you can apply along this tangential direction, So this is. Then if we applied a force along this tangential, then it rotates along this direction. Think about your bottle cap. If we turn along this direction, then the cap moves upward, and if we turn along this direction, then the cap goes downward. So this is the two particular convention, and it is clear from your bottle cap. So if we apply the force along this direction, then it turning anti-clockwise direction. Anti-clockwise means you have to follow the clock. So this is the anti-clockwise direction, and it is denoted as, and this is anti-clock sign, upward sign, and this is, if we apply it along this direction, then it goes inward. So this is the inward sign, this is inward, and this is outward. It is representation only, outward, for the viewers, for the readers. If on a particular book this particular sign is given, then you have to think that it is inward to that particular page, and it is outward to that particular page. So if we applied a force along this direction, then it is turned along anti-clockwise direction. If we applied a force, then it turns along this particular direction. So this is when it turns along anti-clockwise direction, then it is taken as positive, and when clockwise direction, then it is taken as negative. So when torque is positive, suppose this is simple balance, and a force acting along this direction, F1, and this is also a force acting along. If F1 acts along this direction, then it tries to turn it with that particular direction. So this is clockwise. So clockwise means negative. So if this distance is d1, then we can write F1 d1, and this is clockwise means negative, so minus of F1 d1. And if this force is greater than particular force, then it turns along this direction. And we always see in a particular market the simple balance, how to wait, we can buy something. So when F2 is greater, then it turns along anti-clockwise direction. So anti-clockwise directions mean positive. So F2 D2, and it is positive. So these two are the conventions. So convention of clockwise and anti-clockwise movements. So this is called anti-clockwise movement, and it is taken as positive, and clockwise movement, and it is taken as negative. So you can write here clockwise movement equal to negative, and anti-clockwise movement and it is taken as positive. So there are two types of movements basically, clock and anti-clockwise movements. That is the turning of this body. If suppose this is a pen, if we applied a force along this direction, that this pen, you will see particularly, I see that this is clockwise, and you see that this is anti-clockwise direction. So for the particular viewers, this is anti-clockwise, and this is a clockwise movement. If that particular force is greater than that one, then this rotates in a clockwise direction. Okay. So when you think that this is anti-clockwise direction, then take positive sign, and when you think that is clockwise direction, then take negative. So these are the conventions of clockwise and anti-clockwise moments. And the next one is couple. And if we think about the turning of bottle cap, if we think about the key in a particular lock, or if we think about the turning of a steering, so all the concepts, all the particular facts are related with couple. suppose you think that this is a steering and this is a steering, and if we applied a force like that, then this is along this direction and this is along this direction. So there are two forces, two equal forces always acts in, and this force can turn this body along this direction and this force can turn this body along this direction. So this is clockwise pattern. If we force along that particular direction, this is clockwise. So two moments are negative, and if we turn along this direction, then two are anti-clockwise directions. So there are two forces, and this is called, so every turning phenomena are associated with two forces. This is called couple. So couple is a turning effect caused by two equal forces. So you can say that. What is couple? The next question is, what is couple? So the next question is, what is couple? What is couple? What is couple? So couple is a turning effect. So couple is a turning effect caused by two equal forces. Two equal forces. And the next concept is MOC, moment of couple, equal to F into perpendicular distance. So if we applied this is a bar, and suppose this is like a steering, you can take. So this is a force and this is another force F, and this is a particular point, suppose O, and this is A and this is B. This is B. So that particular distance is OB and this is OA. And if we take a particular force, suppose moment of couple, moment of force, suppose moment of force F at B. Always try to say that moment of force about O due to force at B. Moment of force about O. Because O is the pivoted point. So moment of force about O. Moment of force about O at B. Equal to F into OB. Similarly, moment of force about O at A equal to F into OA, force into perpendicular distance. So total, so this one is clockwise moment and this one is also clockwise moment. So total moment, that is couple. So couple equal to FOB plus FOA or FAB. OA plus OB, there is AB. So couple equal to force any one of the equal forces into the perpendicular distance between the equal forces. So this is the perpendicular distance between the equal forces. So you can write any one of the equal forces, into any one of the equal forces into perpendicular distance between the equal forces. So any one of the equal forces into the perpendicular distance between the equal forces. So this is the distance, AB is the distance, and so all the points are completed, and wait for the next class, and the next class is for equilibrium. So thank you.